Hello, my dear learners. Our today's topic is going to be gravitation and its laws. So, let us move further and start our topic. So, to understand gravitation, let us first try to know that what is gravity. As we all know, there is a force between Earth and its objects, which keeps the objects on Earth in their place, and that is why this force is known as what? It's the force of gravitation. So it is a very simple term to understand that the force of attraction works between every object which is in the universe. So force of attraction, because of the force of attraction, the sun and its planets are there in a orbit. Okay, so sun is in the center and other planets are revolving around the sun because of any kind of force of attraction, right? So specifically, this force of attraction which is being applied between Earth and its objects will be known as what? Gravity. So as we have counted two terms above, that the force of attraction and gravity. So here's is a question that what are these terms and how they are related to each other. So let us move further to understand these terms, and here are the answers to the previous questions, and the answer was yes to the previous question. It is explained below that the force of attraction is universal force which acts between any two objects or bodies, which results in attracting or pulling these objects towards each other. What does it mean? It simply means that there is a kind of force of attraction or a pull between the universal objects or the bodies which results in attracting or pulling. Those objects are pulling each other towards themselves. Like this force of attraction between any two objects is directly proportional to their masses and is inversely proportional to the distance between them. What does it mean? Like, it is very simple to understand. Okay, so let us take the force of attraction is F. The force of attraction is what? It is F, and the gravitational constant is G. Mass between those two objects is taken as m1 and m2. It is simple. Okay, so G is the gravitational constant here, and D is what? It is the distance between those two objects. If I'm talking about like the forces of force of attraction between any two objects is directly proportional. What does it mean? It is directly proportional. Like, force is directly proportional to the masses of the objects. Force is directly proportional to the masses of the objects, and it is inversely proportional. Like, if I'm talking about inversely proportional, then what does it mean? It simply means that, like, it is inversely proportional to the distance between those objects. Okay, so distance will remain same between those two objects. Like, suppose the sun is here and the planet is here, and the distance between the sun and this planet is taken as d. If I take it from planet to sun, then it will also be d, and if I take it from sun to planet, then also it will be d. So distance is taken here as d, and the mass of first object, let us take the mass of sun m1 and mass of the planet m2. Okay, so masses are taken as m1 and m2. So this is how the force of attraction between any two objects is defined, and v is taken as constant whenever I will be going to remove these proportionality sign, then I will be getting a constant over there. Like, if I combine equation 1 and equation 2, then I will be having equation like this: F will be proportional to, on combining equation 1 and 2 will be m1 m2 upon 3. So this will be my final outcome. And if I remove this proportionality sign, it will change into equal to sign, and it will give a constant here which will be known as the gravitational constant. Hence, through this relation, we can easily understand that gravitational force is a type of force of attraction, and there are numerous force of attraction that exist in nature. Some of them are like gravitational force, and magnetic force, electrostatic force, and also there are so many other forces which exist in nature. Here we have to learn about gravitational force. So as we know that gravity, we were talking about gravity. Gravity is kind of an invisible force. Like if I am taking this pen and if I'm putting it like I'm throwing it down, it will not come towards me, it will go towards earth. So this is how we can understand that gravity is a kind of invisible force which I cannot see, which you cannot see, but we can feel it, like when the object is pulled towards earth. This is a kind of force that pulls object towards each other, and earth's gravity is what it keeps us on the ground and what makes things fall. Like if I was talking about, like if I throw a pan, then it will go towards where? It will go towards earth. Okay, so if you can also see Newton is sitting here, and this is how he discovered. Let us now understand that what kind of force that gravity possesses to keep the objects in place or to make them fall over the earth's surface. Okay, so for that, we have to move further. Now, taking a reference to the previous data, we come to a conclusion that gravity possesses nothing else but the force of attraction between two objects, and this force of attraction is known as gravitational force. This is what we have already understood. Okay, now this law had been given by Sir Isaac Newton, which I was talking earlier about. It is said that he realized about gravity when he saw an apple fall down from a tree. So at that time he was thinking like what is making the apple to fall down. So now Newton came up with a law which is known as the Newton's law of gravitation, which states that any particle of matter in the universe attracts any other particle with a force varying directly as the product of the masses, which we talked about earlier. Like F is directly proportional to m1 and m2, and then it is inversely proportional to the distance between those objects. And here we were taking a constant which is like F is equals to G m1 and m2 upon D. Here's G is a constant which is known as universal gravitational constant. It has a fixed value which is like 6.674 into 10 to the power minus 11 Newton meter square per kg. Okay. Now, for understanding about gravitation more, we have to see some data about it. Like if I talk about Sir Isaac Newton, then he put forward the law in 1687, and he used it also to explain the observed motion of planets and their moons, which I was talking earlier in the video. Okay, now further, this had been reduced to mathematical form by Johannes Kepler early in the 17th century. This makes clear that the Newton's law of gravitation not only defines the Earth's gravity but also further reducing to mathematical form by Johannes, it gives information about planetary motions. So in aspect of that, there are three laws of Kepler which are as follows. The first law states that the planets move in elliptical orbits. Planets moves in elliptical orbit with sun as a focus. So this was the first law of Kepler, which states that the planets move in an elliptical orbit with the sun as a focus. Now second point states that a planet covers the same area of the space in the same amount of no matter where is it in its orbit. Like if I take it as, like suppose that planet is here and the planet is here, the area covered here will be equal to the area covered here. Okay, so if planet is moving like from here to here, it is covering the same area when it is moving from here to here. Okay, take two reference points over here now. So this was the second law of Kepler, which states that a planet covers the same area of space in same amount of time, no matter where it is in its orbit. And the third point states that a planet's orbital period is proportional to the size of its orbit. Like its orbital period will be proportional to the size of its orbit, which means that the farther a planet is from the sun, the slower its orbital speed, and vice versa. Okay, so now let us move further. So till here, I guess we have understood so many things, and there is a scientific argument about like gravity. Einstein argued that gravity isn't a force at all. He described it as a curvature of time and space caused by mass and energy. So this is a kind of question which will keep you like going and continuing search of gravitation and gravity. So what are your views about the same? Answer it in the comment section. And thank you for watching the video.